Hey everyone, this is part two of a three-part lecture series on understanding the Research FRQ. Last time we were together, we went over these first two items on our list. We talked about research design, and when you're reading an FRQ, trying to figure out, first of all, is it descriptive research? That would mean case studies, surveys, and naturalistic observation. Is it some kind of correlational study, which looks at the relationship between two factors? Or is it an experiment where they manipulate the variables and measure the results, looking for cause and effect? We then talked about the methodology itself, and the methodology is just the nitty-gritty details of what exactly did the researchers do. The research design is the type of research. The methodology is what did they do? How did they study what it is that they studied? So today, this part of the lecture is going to look at interpreting results and looking for errors in research. These are two common things that they ask on the FRQ. You won't see them every single time, and so it's possible they won't ask you to look for errors or something like that. But I've seen enough FRQs to know that you should be aware of both of these things as you prepare for the AP exam. So first, let's look at interpreting results. When we're looking at results, it's important to remember that there's a couple of different types of statistics that we look at in psychology. We have what are called descriptive statistics. And descriptive statistics, you can look at all of the data points that gave you that particular result. And so, for example, I can look at a test average for my class, and maybe the test average is an 82%. And if I want to know how to get that 82%, I can look at every single data point that gives me that particular statistic. Inferential statistics, on the other hand, is when we try to draw a conclusion or make an assumption that is based off of a sample. And we use inferential statistics all of the time because we cannot realistically study everyone. And so maybe we come out with a new drug that maybe it's an anti-anxiety medication, and we say that it works with 80% of people who suffer from anxiety. Well, they haven't tested this drug with every person on the planet that has anxiety, but instead what they've done is they've tested this using some particular sample. Maybe they looked at 2,000 people who have anxiety, and they found that the drug worked with 80% of them. That is an inferential statistic. They've drawn a conclusion based off of a sample. The larger your sample size and the more representative your sample, the more likely that your inferential statistic is in fact true or genuine. We also want to look at these different types of statistics in regard to what are they telling us about the data. We have what's known as a measure of central tendency, and those are, I think, the mean, median, and mode, right? What you learned a long time ago. And they tell us a little bit of different stuff about the data itself. The mean being the average, of course, the median, which is the middle data point, and the mode being what happens most commonly. Those are all measures of central tendency, right? What tends to be in the center. If the mean, median, and mode all line up, we have what's known as a normally distributed bell curve. And you can see on the chart here or on the slide here, that would be a normally distributed bell curve because the mean, the median, and the mode are all together in the center. Sometimes, because of outliers, you might have the mean or the average be greater than or less than the median in the mode. And this is what we call skewed distribution. You can have a positively skewed distribution when that average is greater than the median in the mode, and you can have a negatively skewed distribution, and that's when the average is less than the median in the mode. If I give a test to my class of 30 students and I have one student absent that day, well, the test average is probably going to be much lower than the median in the mode. It's going to be negatively distributed or negatively skewed because of that 0% in the grade book, right? If we take the average age in the classroom with all of you and myself included, it's going to be positively skewed because I'm twice as old as most of you, and so it's going to bring that average up. And then we have what's called a measure of variance, and think variance, how much it varies. Range is pretty straightforward. You've learned about range for a long time. You essentially take the greatest data point and the smallest data point, and you see what is the range of data. And then we have that standard deviation. And the idea behind standard deviation, if you just think about that phrase, how much are we deviating, right? How much are we deviating away from the standard, from the mean? And so if I have a test average and it's an 83%, I want to know, well, is the data really consistent? Did a lot of the students score right around an 83%? Or is the data all over the place and you just end up with an 83% as the average? Small standard deviations mean that the data is very, very consistent. If you've got a really large standard deviation, that means that the data is all over the place. So standard deviation talks all about consistency. You can see, again, if we look at that bell curve on the bottom right-hand corner there, this is looking at the standard deviation of a normally distributed bell curve. And you can see that if you score within one standard deviation of the mean, one standard deviation above and one standard deviation below, that makes up about 68% of the population. Two standard deviations from the mean is 95% of the population, and three standard deviations from the mean are going to make up 99% of the data. What does that mean? Well, here you have the average IQ score. The average IQ score is 100, and a standard deviation for IQ is 15. So if you scored one standard deviation above the average, you scored a 115. If you scored one standard deviation below the average, you get an 85. And then one standard deviation within the mean, so it's above or below, that would be anyone who scores between an 85 and a 115. That's about 68% of the population. And then the next thing I would say here, and I've seen this show up a bunch on the FRQ, is talking about what we call statistical significance. And with statistical significance, we're thinking it's not whether or not the research is important, right? Statistical significance is really just looking at, is the dependent variable the result of the independent variable? And so we measure that in what's called a p-value. P stands for probability. And we want small p-values. In my last lecture, I talked about how sleep can impact focus, right? Well, I come out with a study and I come up with the result, and I say that if we manipulate sleep and we deprive people of sleep, then they're really going to lose their ability to focus. And so if that's the case, I would want to publish a p-value, a statistical measurement, saying I am confident that the change in focus level is because of sleep. If I had a p-value of 0.05, that's a probability value of 0.05, it means there's a 5% chance that the focus changed for some other reason, but I'm 95% confident that the change in focus was because of the independent variable, because I deprived your sleep. Sometimes if you're looking at a correlation, the results will look a little different. And so with correlations, again, this isn't an experiment. A correlation is just the relationship between two factors, right? We have positive correlations, meaning if one factor increases, so does the other factor, meaning the more you study, the more likely you are to do well on an exam, right? We have negative correlations, which means as one factor goes up, the other factor goes down. As the amount of caffeine you consume increases, your hours of sleep may decrease. That's a negative correlation. And if you're looking at a correlation, there's some things that you can look at. Again, positive or negative just tells us, is it going up or down, right? Is it a positive relationship or a negative relationship? And then the number itself is the strength. The closer that number gets to 1 or -1, the more predictable something is. If you had R equal 0.99, that is an incredibly predictable correlation. If that number gets really close to 0, it's pretty random. Your height in my class and your GPA, there's probably not a strong relationship between those two things. I would guess that R would equal 0.03, right? There's nothing really there. But the amount of time that you spend studying psychology and reading the textbook and your grade in my class, that's probably a very strong positive correlation. And then finally, looking for errors. This is a real common thing they ask for in the FRQ, is they'll give you a study and then you got to figure out what's wrong with it. So sometimes the error is the researchers in the FRQ, and they confuse the methodology. And so I've seen FRQs where the whole thing is describing a correlation, and then they make a claim that X causes Y, right? They say that this is causing that. Well, that can't happen because, again, correlations don't equal causation. You might have an FRQ that's about a case study, and at the end, they try to apply the results to the general population. You can't do that. If you want to have cause and effect, if you want to apply this to the general population, it has to be an experiment. And so sometimes the error is the researchers confuse methodology, or they might say that the researchers publish this, right? And a newspaper picks it up and someone reads about it and they're like, oh, look at this. It turns out that X causes Y. And they're simply confusing methodology. Another common mistake or error that they may have in testing is some kind of error with ethics. And so I have these 4 things listed there that you need to know about ethics and psychological research. Informed consent, right? In other words, people must know that they are participating in an experiment and they have the right, it's voluntary, they were not forced to do this, and they have the right to quit at any time. There was an FRQ a while ago where a psychology professor on a university required all their students to participate in a study. What was the problem? They didn't have informed consent, right? They did not have the choice whether or not to participate. Protect from harm and discomfort. You want to avoid any experiments that may cause physical or psychological harm. I have that picture of Zimbardo's prison study where those participants were clearly harmed psychologically. Confidentiality, we cannot produce or publish, results that have identifying information in them. And so you need to rest assured if you participate in an experiment that you can remain anonymous if you choose to. And then debriefing. Debriefing is making sure that the participants understand what the experiment was all about by the time they're finished with the experiment. They don't have to know at the beginning. Think about Solomon Asch. He had them lining up those lines and he told them it was a vision test, but really he was testing conformity. He was using what we call deception. Deception's okay, but you got to debrief at the end. You got to tell them what this experiment was actually about. And then lastly, some errors that you might see when reading the FRQ deal with a bias. And there's lots of different types of biases with psychological study. Hindsight bias, right, is the I knew it all along. Right? Hindsight bias is now you have the results and you claim you could have predicted it. Oh, I knew that that was going to happen. Well, you know it because it's already happened. Confirmation bias, real popular FRQ term. Confirmation bias is when researchers, sometimes called researcher bias, researchers are looking for evidence that supports their belief. If they believe that boys are more hyperactive than girls, they may pay more attention to those boys than the girls because they're trying to confirm what they already believe. They're trying to confirm their hypothesis. And then overconfidence is this strong overestimate in a particular result or belief. Don't overthink this one. Overconfidence is simply the idea that you claim that more people agree with you than actually do. You claim that more people could have fallen into this one particular group than actually would have. For example, we have lots of people who are Democrats claim that more people disagree with Republicans, and we have Republicans claim that more people disagree with Democrats because overconfidence, you tend to believe your own personal things and think lots of other people agree with you. So that was pretty quick as we broke down the last 2 parts of the 4-part FRQ. Remember, the type of the research, the methodology, interpreting results, looking for errors. Be on the lookout for those 4 things when trying to tackle the Research FRQ. If you have any questions at all, don't hesitate to reach out. Good luck.